I'm Anil Kumar sharing with you a very important test question on periodic trigonometric functions. We are doing modeling of functions. The question here is, the number of hours of daylight in Vancouver can be modeled by a sinusoidal function of time in days. The longest day of the year is June 21 with 15.7 hours of daylight. The shortest day of the year is December 21 with 8.3 hours of daylight. Graph the function for one complete cycle. Part B is write cosine function to model this situation. C is write an equivalent sine function, and D is predict the number of hours of daylight in Vancouver on January 30th. Now what we are given here is maximum daylight. So let's say maximum is given to us as equal to 15.7 hours. Minimum daylight is given to us as 8.3 hours. Now that gives you the average value or the axis. So let's say axis is average of these two. So we can do 15.7 plus 8.3 divided by 2, which is 0.0, and this gives us 24 divided by 2, which is 12. So the axis is 12. Amplitude A, let's say amplitude, is equal to, we can find their difference and then divide by 2, which is 15.7 minus 8.3 divided by 2. The other way is, from maximum you can take away the average. What you get is 3.7. So I'm not doing calculation showing you this, but 15.7 take away 12 will give us 3.7, which is the axis. Amplitude, right? Now time period is given to us as 365 days, which will give us the k value as 2 pi divided by 365. Now, important thing to find here is the phase shift. What do we notice here is that on December 21st, we have a minimum, right? So let's look into this part. The minimum on December 21st. That means 10 days before the year ends. So 10 days before end of the year. We have a minimum, right? So that means we could think about a cosine function starting 10 days before with a minimum. So that should give us the graph and the phase shift. So we're looking for a phase shift. Let's say, let me write down here, phase shift is 10 right or left, right? So moving left, 10 units left is the phase shift. So using this information, I'll make a very rough sketch here, which will be good enough for our calculations. In your test, you will be provided with the graph paper, so you could actually accurately graph your function on that paper. So here is a very rough sketch with accuracy good enough to give you the results. So maximum is 15.7. Let us say this is the maximum limit for us, 15.7. The average is 12 and minimum is 8.3. So let's say this is 8.3 for us. Okay, let's keep it like this, 8.3. The average is between the two, so we'll call this as 12. Let's complete the cycle of 365 days here. In that case, I could sketch the function 10 days before, right? So 10 days before. So 10 days before we'll have a minimum here, and somewhere in between we'll have the maximum. So the graph will look like this. Right? So that becomes one cycle, right? So what I'm trying to say here is that this point of minimum is at minus 10. That's what I'm trying to say. So this is 365, right? So this point minimum here is at 355, 10 days before, right? 21st December. And somewhere here in the center, which is June 21st, we have a maximum. You could also calculate these days, which will be half of 365. Let's do. So 365 divided by 2 gives you in decimals 182. We can take away 10 from here. So we get around 172, right? So let me write down 172 here to give you the maximum point. Okay. So this is 12 for us. The maximum is 15.7 and 8.3 is minimum hours. So this is daylight in hours, and these are number of days. Let me write D here. So I hope that is perfectly fine. Okay. Now, for sine function, we'll use this as a starting point. Now let's write down the equation for the cosine function. So we have done the graph part. Let's look into the cosine function now. So in general, the cosine function could be written as daylight, let me call this as light, as a function of days will be equal to amplitude times cos of k d minus phase shift plus axis. So let's call this as q, right? So that is the general equation. We have found all the values. So we can say the daylight is. We are starting from this point. So negative cosine. So negative amplitude is 3.7 cos. K value is 2 pi by 365. Let me write 2 pi by 365. This is pi. Okay. And phase shift is for 10 days. And because it is on the left side, we'll make it negative. So negative makes it positive. And shift is by 12. Correct? So that becomes the equation for us. So we've done part B, which is here. Now part C is to write equivalent sine function. So equivalent sine function could be written as, let me write down, L of daylight will be, now we are considering that point, which is quarter of the cycle to the left, right? So quarter of the cycle is how much? 365 divided by 4 in decimals is 91.25. Let's take this as 91. And since it starts here, so that point is 81 away, right? So we could take this 81 away. Half of this you can say. So we get this as 3.7 sine 2 pi by 365 times d minus 81 plus 12, right? So that is how you can get the sine function. So sine and cosine are related with quarter of the cycle. Now part D is predict the number of hours on 30th of January. So let's calculate this now. 30th of January will be 30 days in the year. So light on the 30th day will be, we'll use the cosine function, minus 3.7 cos 2 pi over 365 times 30 plus 10 plus 12. Okay. So let's use our calculator. Setting should be in radians. So let's make sure that part. 4 is radian for this. Now we have minus 3.7 cos of, within brackets, 2 pi, let me write times 40, and then we'll divide by 365, bracket close, 2 brackets, okay, and then we'll add 12 to this. So we get 9.14, right? So we get this value as equal to 9.14, or we can round it to 9.2, right? So it could be rounded to 9.2, let's say 9.2 hours. So that becomes the daylight on 30th of January, right? So that is 9.2 hours. So that is how you could actually solve this particular question. So I hope it's absolutely clear. So let's move on. We are almost at the end of our test paper. Here's question number 16. State one interval between minus 4 pi and 4 pi where the function y equals to 5 cos x by 2 plus 1 has an average rate of change that is 0 and part B is a positive value. Now in such questions, it is good to sketch the graph. So let's sketch the graph and then we will do the needful. The function given to us is y equals to 5 cos x by 2 plus 1. That means the time period here is, time period will be 2 pi divided by k, which is half in this case, so it is 4 pi. So that's the time period. So one full wave in 4 pi. Since the interval is from minus 4 pi to plus 4 pi, we will have one wave, cosine wave on the right side and one on the left side, and it's shifted 1 unit up. So we can say this is 1 unit up, right? So that is 1 unit up. This is at 1. Now, okay, we have maximum will be 1 plus 5, which is 6. So this is 1. Let's say, let me just extend this a bit more. Okay. So if I add 5 to it, so this is at 1, right? So if I add, let us say this is our maximum value, which will be at 6. 5 plus 1 will go down by 5 also. So that will be at minus 4. Perfect. The cosine function starts with the maximum and ends with maximum, right? So the wave will be kind of like this. So I'm trying to end it here itself. So, and this wave ends in 4 pi. So let me just extend this. So this one wave will be ending at 4 pi, right? 0. Similarly, on the left side, we will have this wave as, let me just make approximately. It looks much longer. Anyway, you get the point. So this is minus 4 pi for us. Okay. Yeah. So that becomes from minus 4 pi to plus 4 pi. Right. Now we need to find interval where the average rate of change is 0. When we say average rate of change is 0, then we could select 2 points which are at the same level. Does make sense to you, right? So which are at the same level. That is what is important for us, right? So from the symmetry, you can say that for part A, for average rate of change equals to 0, we could be same distance away from both because of the symmetry. This is an even function, right? And therefore, I could use a value which is, let us say, minus pi within this interval from x equals to minus pi to x equals to plus pi. Do you see that? So x1 and x2 could be minus and plus pi, correct? So that will give us average rate of change as 0. So symmetric about the y-axis. That's the whole idea, right? So we can get 0. Now we want a positive rate of change. Then the positive rate of change could be from minus pi to, see, this is 4 pi, right? So when this is 4 pi, let's see this portion, right? This is 4 pi. So half of the wave is 2 pi, and the quarter of the wave is pi for us. So we are saying this is pi for us. Do you see that? So for positive, the minus pi, I mean. So for the positive, which is part B, positive average rate of change is from the interval where x1 value is at minus pi and x2 is at 0. So that gives us positive rate of change, correct? So as you can see, if I join these 2 points, that is my positive rate of change. And if I join these 2 points, then this horizontal is 0 rate of change. So I hope that makes sense, right? Similarly, you could find many other points, correct? Let's move on to the next question, which is question number 17. Question is, state 2 points where the function y equals to 5 cos x by 2 plus 1 has an instantaneous rate of change that is 0, right? So, well, the graph which we had just sketched, let me make a smaller version of this now. So let the graph be kind of like this now. So I'm making a smaller version just to explain the point. So we'll start with the maximum, go down, up, go down and up, right? So we saw that is the kind of wave which we are looking for, where this is the y-axis, 1, and so it's kind of that is the x-axis, right? So that is a wave where the time period here, this is at 4 pi and this one is at minus 4 pi. So that was the function y equals to 5 cos x by 2 plus 1, correct? Okay, so this point here is 6 and this point here is minus 4, correct? So that is how it is anyway, and the axis is at 1. Now we need to find a point where instantaneous rate of change is 0. So we are looking for instantaneous rate of change equals to 0. So the point is, you can say it x equals to 0. So all the turning points, right, will give us the right answer, or it could be plus minus 2 pi, or it could be plus minus 2 pi, right? So at these points, turning points, so at turning points, instantaneous rate of change is equals to 0, right? So those are the answers. So let's move on to the next question, which is the last question for this exercise. Question 18. Prove the identity sine square theta plus cos square theta equals to 1 for any general point pxy that makes an angle of theta with the positive x-axis. So let's sketch the diagram which will help us prove it. Let's take a general point P somewhere in quadrant 1 is better. Okay, so let's say this is the point P, which is xy for us, and it makes an angle of theta with positive x-axis, correct? We need to show or prove the identity sine square theta plus cos square theta is 1. So that is x, this is y, and that is the origin. So if I drop a perpendicular from here, then let's say the point here is P, and let's call this as Q. In that case, OQ is x and PQ is y. The length OP is r, which could be written as x square plus y square square root, right? So what we have here is a right angle triangle where we could write OQ square plus PQ square equals to OP square, right? OP square. Now OQ square is x, so we could write this as x square, that is y, and this is r square, right? This is r square. Now if I divide all these by r square, what do I get? So x square by r square plus y square by r square will be equal to r square by r square. Now x over r is cosine theta, right? So this could be written as cos square theta, and y over r is sine, so it could be written as sine square theta. R over r is 1. So what do we get here? We get cos square theta plus sine square theta equals to 1. Now that is the Pythagorean identity for trigonometric functions, right? So I hope that makes sense. So in the next unit, we are going to talk about trigonometric identities and equations. So next unit will be trig identities and equations, right? So I hope up till now the modeling of trigonometric functions and working with their ratios and reciprocal functions is absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. All the best.